Okay, in this particular video now, we're going to be looking at the same kind of thing. Again, we are always looking for common bases. So notice that we have the same base in both of these, which is 64. So we have 64 to the 1/3 times 64 to the 3/2. So what I would do is because I have the same base, I know in this case I'm going to add up those powers. Of course, I don't have the same base, so that would be 3/6 plus, and then I'm sorry, 2/6. Can't multiply when I'm doing this. So notice here that, of course, the 3 goes into 6 twice, so I have to multiply the 1 by 2. 2 goes into 6 3 times, so 3 times 3 is 9, so that is 11/6. So I have 64, 11/6. 6 goes into 11 one time, so I can take out a 64. And I have 5/6 left over. So that says a lot. I've got a lot of numbers that I'm really dealing with there. So I'm going to not worry about this 64. I have 64 to the 5/6, which I can actually start working with. But I'm noticing that I probably could have made this a little bit easier by looking at these numbers right away and kind of determining what they are. But we'll kind of continue going down this step, and then I'll show you a little bit faster way. And then we'll do that last problem on this video, and then move on to that next set right after that. So I have 64. We already know that 64, because we did this in a problem just a little while ago, is really 2 times 2 times 2 times 2 times 2 times 2 to the 5/6. Now, this 6 in the denominator tells me that I need 6 of the same number to take one out. So notice 1, 2, 3, 4, 5, 6. So that means I can take out a 2, but I still have it to the 5th power. So that's now going to be 64 times, and 2 to the 5th is 32. And if we multiply those out, I get 8, 12, 12, 19. I get 2048. We get an answer of 2048 in that particular case. And on the last one now, I'm going to distribute this 3/2 through to both. Now remember that I have this rule: if I have x cubed, x squared to the 4th, and again, not x's on both of them, because I could just combine them, but I'm going to multiply the 4 into all the terms that are in there. And if there's a number in there, I would also not multiply the 2 there, but I mean the 4 there, I multiply the power in there. But if it's division, I do the same thing. So let's say I have 2x squared over y cubed to the 4th. Then that would give me 2 to the 4th, x to the 8th over y to the 12th. And then, of course, I have to figure out what 2 to the 4th is, which is 16. And so the final answer, if I were doing this one, would be 16x to the 8th all over y to the 12th. So that's what I would do if I had that. So now what I'm doing is I'm going to distribute this through to both of the terms. So I have 9 to the 3rd times 3 over 2 divided by 4 squared times 3 over 2. And that means that I have 9 to the 9/2 over 4 to the 6/2. So notice 2 goes into 9 4 times, so I can take out 4 9s. I have 1 left over. On the denominator, I have 4 to the 3rd, and I have nothing left in there because 2 went into 6 evenly. So if I were to do that one, 9 to the 4th is 9 times 9 times 9 times 9, which is 81 times 81. One 16, 1, 5, 65, 61. So that would be 65 6561 divided by 4 to the third is 64. 4 times 4 times 4 is 64. And then in the numerator, I still have this 9 to the 1/2 power, which converts to 3. So I have 65. Well, and actually, does 3 go into? No, 3 doesn't go into 64. So 6561 times 3, 3, 18, 15, 16, 19. So I have 19,683 all over 64. So that would be my answer for number 4. And now we're going to do the last ones on the last video.